So this is our review for the Unit 5 practice test. Let's start with number 1. It says 3 times the tangent of theta is 1.835, and theta is between 0 and 360. So I need to make sure that my calculator is in degrees for this problem. So I'm going to do that right now. It's in radians, so I'm going to switch that to degrees. And I've got to find theta. So I've got an equation to solve. I'm going to divide both sides by 3. And I get that the tangent of theta is equal to 1.835 divided by 3. I take the inverse of each side. And I get that theta is equal to the inverse tangent of 1.835 divided by 3. Because it's positive, I realize that theta for tangent is positive in these two quadrants here. So I'm going to have a quadrant 1 and a quadrant 3 answer. And all I'll have to do is, when I get one of these answers, is add 180, because it's diagonal. When you go across a straight line, that's adding 180. So let's use our calculator and do inverse tangent of 1.835 divided by 3. And I get, does it say what to round to? It doesn't. Let's go to 2 decimal places. 31.45 degrees. That's going to be one of my answers. And my other answer is going to be diagonally across the circle, across the straight line. So I'm going to add 180 to this, plus 180. And I get 211.45 degrees as my other angle. Okay. Number 2 says to the nearest thousandth, so that's 3 decimals. What is the cotangent? Oh, I get to skip this one because we did not do cotangent. So you get to skip number 2. All right, the third question. The sides of a triangle are 12, 14, and 16. What is the measure of the smallest angle? So this picture here actually goes with number 4. So I need to draw a picture for number 3. So this is for number 3. And the sides of the triangle are 12, doesn't matter where I put them, 14, and 16. What is the measure of the smallest angle? Well, smallest angle is across from the smallest side. So this is the angle that I'm looking for. Right? And whenever I have side, 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 I remember that I use law of cosines. So I guess I'll call this x. Well, actually capital X, because it's an angle. And so I'm going to use law of cosines. Remember the part that's highlighted, that's going to be the 12 squared equals 14 squared plus 16 squared minus 2 times 14 times 16 times the cosine of x. So I'm going to use my calculator. I know what 12 squared is. That's 144 equals, so my 14 squared plus 16 squared. And I get 452 minus 2 times 14 times 16. It's 448 cosine of x. Then I can't get these together because this 448 is attached to the cosine of x. So I'm going to subtract 452 from each side. And 144 minus 452, I get negative 308 equals negative 448 cosine of x. Going to get rid of this negative 448 by dividing. And I get that the cosine of x, let's see what's negative 308 divided by negative 448, 0.6875. Take the inverse. And because it's an angle, I only want the positive. So I'm going to take second cosine of 0.6875. And I get, and it said, did it say what to round to? It did not. 46.57. I'll just go to 2 decimal places. I guess I could go to 3 and say 0.567. So 45.567 degrees. If it asked to the nearest degree, it would be 46 degrees. Okay? Okay, let's go to number 4. It says, using the picture above, what is the area bound by the 4 streets? Okay. Area, well, let's see. This is, if I could find the area of this triangle, these two would be the same. I could double it. So let's see if we can find the area of this triangle. We know side angle side, so remember we have that formula, area, well, yeah, area equal, I'm going to write out the word area equals 2 of the 1/2 times 2 of the sides, A and B, times the sine of C. So 0.5 times the 72 times the 81 times the sine of 52 degrees. And what do I get when I do that? 0.5 times 72 times 81 times sine of 52. And I get 2,297.839,358. And that is the area, though, of only this triangle. So I need to double it. So 2 times the 2,297.839,358. So times 2, and I get an area of 4,595. Does it say what to round to? It does not. Let's just say 0.68. And that would be feet squared. Using the picture above, where the dotted line represents the fence, how many feet of fencing is needed? So this right here represents my fence. So I'm looking for this missing side, which is across from this angle. And I have side angle side, so I can use law of cosines. This side we'll call x squared equals 72 squared plus 81 squared minus 2 times 72 times 81 times the cosine of 52 degrees. Nice thing about this one is because there's no variables here, I can type all of this into my calculator. 72 squared plus 81 squared minus 2 times 72 times 81 times the cosine of 52. And then I take the square root of each side. Don't need plus or minus because it's the length of a side. And I get 67. Does it say 56 feet, or 68 feet if they wanted it to the nearest whole number. Okay. Let's look at number 6. We're asked for the measure of angle B. Now I want you to notice that this is a right triangle. So we don't need log sines or cosines. We can use SOHCAHTOA whenever we have a right triangle. We want the measure of angle B. This is what I'm looking for right here. So I could do, and this is my hypotenuse. So sine would be 10 over 5 square root of 5. Cosine would be 5 over 5 square root of 5. Or tangent would be 10 over 5. I think I'm going to go with tangent. Tangent of B equals 10 over 5. In other words, tangent of B equals 2. So to find B, I just can take the inverse tangent. So B equals the inverse tangent of 2. And I'm still in degrees. Yep, inverse tangent of 2. 63.43. So B is 63.43 degrees. Okay, let's go to number 7. Triangle MNP. Angle M is 66. Angle N is 34. And side M is 15. And I'm looking for side N. Let's see. So I have both of these, and I need this one. I'm going to use law of sines here, which says that the sine of 66 degrees divided by the side opposite equals the sine of 34 degrees divided by the side opposite that. Cross multiply. 15 times the sine of 34 equals n times the sine of 66. I'm solving for n, so divide by the sine of 66. And I can just put all of this in my calculator. So I've got 15 times the sine of 34 divided by sine of 66. And is 9.18. There we go. Let's look at number 8. What is the exact value of the cosine of C? Cosine is going to be adjacent over hypotenuse, which means I need to find this hypotenuse, and it's a right triangle. Well, Pythagorean theorem. That's something that we can use for number 8. So 8 squared plus 11 squared equals, I'll just call it x squared. So we've got 64 plus 121 equals x squared. So x squared equals, let's see, that'd be 185. So x is the square root of 185, because I took the square root of both sides. Now, I don't think that can be reduced. 185 divided by 25. Now, and I can't think of any other perfect squares. 185 divided by 64. No. I can't think of any perfect squares. 185 divided by 81. 185 divided by 49. No, doesn't go in. So this is the square root of 185. So the cosine of C is 11 divided by the square root of 185. Because cosine is adjacent over hypotenuse, and we're looking for the cosine of C. So it's adjacent over hypotenuse. We need to rationalize the denominator.